All right, so you looked at this graph in the last activity, and hopefully what you noticed is that uranium, nuclear power, is actually the largest source of power in Ontario. That's where we get over half of the electricity in Ontario from. So we'll talk a little bit more about nuclear, about how it works, what some of the pros and cons are, and then also some other applications as well. It is such a significant source here in Ontario that it's an important one to look at. So first of all, where does nuclear power come from? Well, it comes from uranium, which is a type of atom. It's a type of material that shows up on your periodic table. And uranium, you can mine it. You have to find sources of it, but if you can find sources of it, you can mine it, and it's just a rock. And it requires some refining. You need to do some work with it before you can use it in a nuclear power plant. But it is a material that you can just mine. And luckily in Canada, we have generally a good amount of it. So uranium, um, if we look at our periodic table, it actually shows up way down here at the bottom. It's a pretty big atom. Remember, the ones at the top are very small atoms, and as you go further and further on, the atoms become bigger and bigger. They have more protons and more neutrons and more electrons in them. So when you get down to these largest atoms down here, a lot of them are radioactive, which means that they're so big that they're able to break apart. Even the nucleus, that center of the atom with those protons and neutrons, that's able to break apart as well. And there's a huge amount of energy that's stored in the nucleus of an atom, inside of an atom. There's energy that's stored that's holding those protons and neutrons together. So if you're able to break apart this atom, you're able to harness that energy. And these materials that are big, these atoms that are huge, these ones are just naturally radioactive. They will, as long as you have enough of it close to each other, they will start to just break each other down and start to release that energy. Now, the pros of that is that there is a huge amount of energy that you can harness. The downside of it is that it also releases radiation that's dangerous, right? Gamma radiation, for example, very high energy. It also releases alpha beta particles. These are types of radiation. And some of the concerns with radiation is that radiation causes cancer, right? So those are the downsides of it. All right, so before we look at the nuclear power plant, let's think back to what we saw in one of our first lessons here. How do you make energy? Well, you only need two things to make energy. You need a magnet and a coil of wire. And even in a nuclear power plant, that's still what it comes down to. You need to spin this coil of wires past a magnet, right? Remember that the magnetic field will push the electrons in the wire. So as long as you keep moving them past each other, you're generating electricity. So even in a nuclear power plant, all you have to do is spin that coil of wires past the magnet, right? That's your generator. All right, so here's our picture of a nuclear power plant, and it looks a little bit confusing at the start here, but we'll kind of look at each different part here. So the idea with a nuclear power plant is that if you have enough uranium, there's other types of radioactive material, but we'll use uranium for now. If you have enough uranium and you put it close enough to each other, it will start to break apart and release energy, release radiation. So that's what's happening over here. And you'll notice that they put it in this big containment vessel. They put it in a giant cement box. And that's to stop the radiation from escaping, right? So that it's safe for people living near it. So first of all, you build this giant cement box. Inside of that cement box, you take your radioactive material and you put it into your reactor. And what you can do is you have these rods that kind of split it up, that break it apart to keep it away from each other. So you can control how much of the radioactive material is close to each other or further away. So what you can do is you can control it so that you just get enough of it breaking down that you're creating enough power, but it doesn't create so much that it explodes. And you use these control rods to do that. So you put just enough of this nuclear material together, it starts to create lots of energy and heat. You use that heat to boil water. So here's our water over here. It starts to boil and it produces steam. You take that steam, you put it through a tube, and you push a turbine with it. You spin a metal wheel with it. And as soon as that metal wheel starts spinning, well, hold on, that metal wheel is attached to your generator. It's attached to your coil of wires that's spinning around your magnet. So right here in the generator, that's your coil of wire and your magnet. So the steam comes along, it spins that metal wheel, which is attached to the coil of wire. It moves the coil of wire past the magnet, and now you have electricity. You have electrons moving in the wires, which you send to, well, here, it looks like a picture of Toronto here. And then they just allow that water to cool down and they reuse it. So that's really all there is to it. Right? Your nuclear material gets really hot when you get enough of it close together. Boil water into steam, push your turbine with the steam, and connect that to your generator. All right, here's a picture of one. I think this picture is actually from one that's in Switzerland. But this little dome here, this is the cement dome where they have the nuclear material. And then they boil that steam, they send it over into this building here, where they have the generator, their magnet, and their coil of wire spinning. And then that's sent out into the power grid to people's homes. This over here is actually a cooling tower. So it looks like it's emitting something. You might think, oh, what is the smoke it's emitting? It's actually just extra steam. It's just excess steam. So that's actually just water vapor that's escaping there. All right, so what are some of the pros here? Well, it generates a huge amount of power, right? From that first graph, over half of the power in Ontario, 60% of the power in Ontario comes from nuclear. If we didn't have nuclear, I mean, we'd have a hard time making enough power. Another nice thing is that it releases no greenhouse gases. It doesn't make carbon dioxide, doesn't make methane, right? So it doesn't contribute to climate change. That's a big one, right? That smoke that you're seeing escaping is not smoke, it's actually just water. And it only generates a small amount of waste. So it only takes a tiny, for example, a tiny pellet of uranium that's maybe the size of your pinky finger, that can power tens of thousands of houses for a whole year. So you only need a small amount of nuclear material to make a huge amount of power. What are the downsides? Well, after it's been used up, the radioactive material, the uranium, is still radioactive. It's still dangerous to handle. And it can take tens of thousands of years in order to become safe to handle again. So it stays radioactive even after you've taken it out of your reactor. So in this case, you end up with this nuclear waste and you have to figure out what to do with it. And there's really no way to make it safe again other than just waiting for it to decay, which takes a very long time. So right now, all we do is we really just bury it in the ground and keep it far away from people, and we're going to leave it there for tens of thousands of years. Other cons, there have been nuclear accidents before. If you remember back about, I think about 8 or 9 years, there was a Fukushima plant in Japan. It was starting to melt down, and there was some radiation that was released, and that did affect people and caused evacuations and caused deaths. And that area is still locked down today as they're cleaning it up. If we think back several decades, there was also the Chernobyl plant that exploded. There was a huge amount of deaths from that as well. So there are nuclear accidents in the past, and people are worried about that. The reactors that we use in Canada, they're called CANDU reactors, and the way they're designed is they are the safest reactors in the world. So we've never had a release of radiation from a CANDU reactor before. Generally, they're quite expensive to build, but considering how much power they're making, it's not that expensive. But they do require quite a bit of security as well. So you need to make sure that this uranium is handled safely and you know where it's at, because uranium can also be used to make nuclear bombs, right? So there's also a huge amount of security around nuclear power plants as well. All right, so what are some of the other uses? Well, considering how much power you can get out of a tiny amount of uranium, it can be used for other things. All right, nuclear-powered submarines. Right? Instead of having to run on diesel or some sort of gas, I mean, you need a lot of gas if you're going to keep your submarine underneath, underneath the water for a long time. Instead, now they've built nuclear power submarines because they just need a small amount of uranium and it can last for very long periods of time. All right. Another big use is the Voyager probes. So these are space probes. They were launched in 1977. There was two of them, Voyager 1 and Voyager 2. And they were sent out just to explore our solar system and beyond. So they were launched in 1977. So let's see here. Now we're in 2020. So that is 43 years ago. So they were launched 43 years ago. And they still work today, both of them. And the reason, and they're now well beyond our solar system. So they've gone all the way past the planets, all the way past Pluto and well beyond Pluto. And they still work today, and we still have communication with them. And the reason that they've worked for 43 years is because they're powered by radioactive material. I don't think they used uranium. I think they used plutonium instead. But that material lasts for a very, very long time. So even just a small amount of it is continuing to create energy today and enough to keep these probes running.